what is SPH method? The smooth particle hydrodynamic, or in short SPH, is a numerical method that is a part of a larger family of meshless or mesh-free methods. For these methods, nodes and elements are not defined as you would normally define in a finite element analysis. Instead, only a collection of points are necessary to represent a given body. For instance, imagine we have this part, and then we mesh it, and then when we activate the SPH particle, we're gonna have a collection of nodes, as you can see like here. So any of the material models, boundary condition and loads in Abaqus explicit can be used in a smooth particle hydrodynamic analysis. So this SPH method is not based on a discrete particle colliding with each other, for instance in compression, or exhibiting a cohesive-like behavior in tension. It's simply a clever discretization method of continuum particle differential equation. So SPH uses an evolving interpolation scheme to approximate a field variable at any point in a domain. The value of a variable at a particle of interest can be approximated by summing the contribution from a set of neighboring particles denoted by subscript j, for which the kernel function w is not 0. So what is the kernel option? We have three different options here. We have a cubic one, cubic interpolation, quadratic interpolation, and quintic interpolation. And the smooth linkage determines how many particles influence the interpolation for a particular point, and this is the formula that we have for it. How we can activate this one in Abaqus? So if you go to the mesh option, you need to set your mesh on explicit and 3D stress. Another important point is that your element should be hexagonal. So either it should be sweep or structure mesh. Then you would have this option here at the bottom that you can activate a conversion to particle, yes. And then here you have a criterion. We have three criterion: time, strain, and stress. We use time when we want to transfer the solid model immediately to the particle. So once we press on a solve, all the solid body suddenly turns to a particle. And also we can give some delay to it as well if you wish to. And also we have criterion stress and strain, that we use this one when we have when we want to use a progressive conversion approach. And then here in a threshold we need to define a maximum principal strain or maximum principal stress. And also here we have PPD as well, which is a number of a particle to be generated per isometric directions, specifying a time-based criteria. And here, as I explained before, is a kernel that we have three options here: cubic, quadratic, and quintic. What are the applications? So I've seen SPH method that have been used in so many different applications, but the most important ones are fluid slushing, wave engineering, ballistic like explosion, spraying, gas flow, bird strike, and for instance another example we can say water jet cutting. We can use the SPH method, or even we can use it for some impact test as well. So that's everything about theory of the SPH method. If you want to have more information about this, you can check the Abaqus help. You may find more information there. Thank you so much for watching.